really going to help you when you get to undergrad to get a fundamental basics in AP chemistry will be what you're learning in general chemistry in undergrad as well. And you're just going to have to build on that when you get to organic chemistry and maybe biochemistry for those of you that are oriented towards the biological sciences major. So again, understanding this material now and getting a really firm grasp of it now with us here at Color is really going to help you guys throughout the future of your undergraduate studies. So basically what we're going to do tonight is I'm going to cover a little bit of material, but I'm basically going to overview what the course and the topics that the exam itself is going to cover. So the AP exams have three main types of questions. One type of question is based on the data analysis set of something that they give you. Another type of question is just based on it's what we call a content question, where it's just alone something that you should know in terms of background knowledge. And the third type of most difficult question is going to integrate the first and the second type. So the third type of question is going to give you a data set, have you analyze that data, but also have you contribute a significant amount of background information to that answer. So three types of questions. So normally what I like to do in my courses is start out with the content, then get a little bit into the strategy, then focus on the third type of questions where we're going to be integrating content and strategy questions. So like I said today, we're going to be going through the different main units that are going to be covered in AP Chem. Let me just scroll down a little more. Francis, do you want to get to the unit overview?
Yeah, can you hear me right now?
Yes, I can hear you very well.
So I'll go through it, but do you mind quickly reintroducing yourself, just because a couple of people just joined and I just want everyone to get your backgrounds again.
No problem. No worries. So for those of you that just joined, my name is Sam. I am a lab professor at St. John's. I have a master's in biological sciences, and I really like general chemistry and organic chemistry. I got A's in all semesters of those courses that I took on my undergraduate studies, and then I had to rely on that content to do really well on my MCAT, because the MCAT tests general and organic chemistry pretty heavily as well. So when I came to France, I thought that this course and the AP Bio course would be best for me to start out on, not just because of my content background with this material, but also my understanding of how standardized exams like the MCAT, like the AP exams, like for bio, the SAT2 exam, how these questions like to be asked by the College Board or by the AAMC or by whatever large organization is running these exams. Because by and large, standardized exams, even though they're made by different companies, the vast majority of them try to get you thinking in the same way and in the right direction. So we're going to be going through a couple of different chemistry overviews in terms of what the course is going to go through. And we're also going to be reviewing some material as well. So the first main content section that's going to be on your AP, it's chemistry in terms of scale, proportion, and quality. As it says here, big idea one. So what does this mean? In a chemical system, of course, we refer to everything relative to the periodic table. The periodic table is basically just a very easy way to organize different atoms and different atom amounts. Different elements are only different because they have a different composition of atoms within those elements, and that's it. That's the difference between oxygen and carbon, atom composition. And that happens on a very, very small level. So one thing that we're going to be talking about in the course is how these interactions happen at the small level, and then how they build up to happen at the big level in terms of a biological system. All right, so that's a little bit about this scale of the interactions of elements and atoms that we're going to be learning about throughout the first unit of the course. Chemistry is really the study of structure. What I mean by that is atomic structure. So once we get a base understanding of atomic structure, we can use these principles to not only get a good understanding of the rest of all material covered in AP chemistry, but get a good understanding of material that's going to help us in our undergraduate organic chemistry courses and in all of our undergraduate biology courses as well. So the second big idea here is talking about something called the chemical property. Chemical properties and chemical structures are, again, entirely based on the atomic composition of each element. This is something that we're going to be going through in a lot more depth. For example, there are certain trends in the periodic table that the AP exam tests very heavily. An example of these trends is something called electronegativity. Just as a very, very, very broad overview, certain atoms have certain elements have properties where they have a stronger pull to electrons than other elements. These elements that have the stronger pull are called electronegative elements. There are very, very interesting interactions and properties and structures that these elements can form that we're going to be going through in more depth throughout the course. But I just want to introduce you guys and talk a little bit about what the course is going to cover. So transformations of matter are another fundamental way of thinking about chemistry. So of course, everyone knows that you have solid, you have liquid, and you have gas, but actually at the atomic level, it's not so distinct. In solid, you have molecules that are in some proximity to each other, and this proximity is different between gas and liquid. I want to save most of that idea for the course, but basically, a solid, liquid, and gas are just different energy transitions between it could be a same given set of elements. So these different transitions actually have different physical properties. So solid, liquid, and gas have different physical properties, and they're normally made up of the same elements. However, different elements have different chemical properties. So this is just an example of the different types of properties that we're going to be learning about, specifically how they relate to transformation of matter. Energy, of course, has a major role in driving both biological and chemical reactions. So a reaction to happen needs to have something called a thermodynamic favorability. That sounds like a little bit of a scary concept, but we're going to break it down more throughout the course. But the main idea is that certain reactions need to have favorable molecular formations in their products from reactants. And these favorable molecular formations are actually going to drive whether the reaction happens or not. And this is all driven by stability. Stability and energy are kind of opposites for the sake of chemistry. So if you have more energy, you're less stable. If you have more stability, you have less energy. So it's kind of a vice versa interaction between energy and stability. And it's this push and pull between energy and stability that drives most reactions. All right. So now, in terms of the main overviewed units that are going to be covered on AP Chem, atomic structure I talked about a little bit already. You also have something called an ionic compound. An ionic compound is basically a molecule linked together by two what are called ionic interactions. An ionic interaction is one element is positive and the other element is negative. Together, they form an ionic interaction. And we're going to be getting into exactly how these elements become positive or negative and how to tell which ones are positive and which ones are negative throughout the course, but that's just a little bit of an overview. Now, within different molecules, you can also have forces that attract these molecules together. A very, very famous example of this type of force is called the hydrogen bond. So, like I just mentioned, certain elements are more electronegative. Certain elements have more of a pull towards electrons. So when an element that has a very, very strong pull towards electrons, for example, oxygen, is going to be bound to an element that has a very, very weak pull for the electrons, for example, hydrogen, hydrogen is going to become a little positive because it's losing those electrons to oxygen, and oxygen is going to become a little negative. We call these partial charges. So intermolecular forces actually give us oftentimes partial charges. And we're going to talk about the interactions of these charges and why they're important and how a partial charge differs from a full charge throughout the course. But that's the base idea behind the importance of intermolecular forces, or how they are commonly represented on the AP, which is IMF. Chemical reactions, specifically, like we talked about before, just a little bit, a chemical reaction needs certain atomic favorability to happen. There needs to be certain thermodynamic stability, which we talked about a little bit before. And I don't want to get too deep into this topic right now, just because it is a little technical. So I'll save that for the actual course. But relative to chemical reactions are two separate but both important fields: kinetics and thermodynamics. So kinetics, of course, refers to speed. This is somebody else entered the waiting room. Kinetics refers to speed of the reaction, but thermodynamics refers to the actual chance that the reaction is going to happen. So if you're kinetically favorable, you happen fast, but if you're thermodynamically favorable, you happen in general. There are certain catalysts, famously enzymes, that actually don't touch thermodynamics and they just affect kinetics. So that's actually a really famous thing that's tested on the AP exam is that biological catalysts or enzymes affect only kinetics and not thermodynamics. There are some very, very famous thermodynamic formulas that the AP exam likes to use. So we'll also go through those formulas and how and in what form they show up on your AP Chem exam. So I say the same thing to my students regarding the formulas. You can have one formula, but I can test you on 5 different ways on how to apply that formula. So that's another thing that we're going to be doing throughout the course. Throughout the latter part of the course, I'm actually personally going to be making a book, and this book is going to have different practice problems that are going to show you how for one formula, I can give you 5 different, completely different applications of that one formula for each given problem. So we're going to be going through how to specifically target each word problem, get the information that you need, and then apply your thermodynamic formula to that problem. And that's probably a quarter of all of general chemistry at the undergraduate level. So that's going to be really, really important when you guys mature into your undergraduate studies as well. Um, Thermodynamics, we chatted about a little bit. So certain reactions happen in what's called an equilibrium. Basically, the fundamental purpose of equilibrium is to keep your body in a homeostasis. The AP also likes to test these big thematic ideas. One very important thematic idea is the concept of equilibrium. Your body wants to be kept in a homeostasis. Your body wants to have, in certain cases, reactants equal to products. Why this happens, we're going to go through in the course a little bit more, but just the understanding of that theme is going to be really, really critical for your AP exams. Acids and bases. So I'm sure everyone has heard of these terms in some way or another before. Basically, an acidic solution has a low pH, and we're going to talk about how a pH actually just measures concentration of hydrogen ions. So certain atoms, certain elements, certain compounds are more likely to give up these hydrogen ions because of atomic stability that we're going to talk about throughout the course. And these acids are also more likely to give up hydrogen ions. So the definition of an acid is a compound that's likely to give up a hydrogen ion. And the definition of a base is the opposite. It's a compound that wants to accept the hydrogen ion. And again, that's all based on a molecular structure that we're going to get through throughout the course as well. So this acids and bases concept touches on a really fundamental idea. So you can have a good understanding of an atomic structure at the micro level from unit 1, but now we need to apply it at a macro level to a molecule, to a compound, to something that's bigger than just the individual atom itself. And that's unit 8. So this balance between micro and macro is another really important theme tested on the AP Chem exam. Switching gears a little bit, so a lot of these thermodynamics equations that I talked about a little bit, we can actually manipulate them to creating energy systems based on atomic structure that are going to generate energy for us, that are going to work for us. And I don't want to get specifically into the technical details just yet, but basically you guys should know that a car engine is an example of a very, very complicated chemical cell. And what a chemical cell is, we'll go throughout the course, but it's basically you can use chemical properties to generate a current, which you can use to do stuff for you. So that's kind of one example of a thermodynamic application and how the AP Chem exam is going to try to give you different real world scenarios and go through thermodynamic applications as they pertain to those scenarios. So that gives us a little bit of an overview on the units. Now we're going to dive a little more deeply into it. So for instance, if you don't mind scrolling down a little bit.
So let me just ask you, do you see this level of chemistry again? Because if you could just go over, you're right now at St. John's, right? You're teaching as an adjunct. What's the name of the class that you teach?
So I teach a few different classes. One of them is biochemistry. So in that class, I would definitely say that maybe even out of these 9 units, 4 of them are very, very fundamental to getting a good understanding of biochemistry. As I think I mentioned, for those of you that may have been at the AP Bio session yesterday, I see the students in my classes that got a good grasp of this material when they took their APs, and students that struggle with the material a little bit did not take AP courses. They did not get 4s and 5s on their AP chemistry exams. They didn't take advantage of the time that they had to absorb this material at this level. Your General Chemistry 1 and Organic Chemistry 1 courses are fundamentally based on all of these different units. So by studying this now, you're not only going to put yourselves in a good position to succeed in high school, but you're also really, really, really doing a great job of setting yourself up for general chemistry, organic chemistry, and biochemistry, which is in most undergraduate institutions, maybe 30 to 40% of all courses that you're going to be taking that relate to science. Not to mention the fact that kinetics and thermodynamics and applications of thermodynamics, so that's talking about units 5, 6, and 9, you're definitely going to see again throughout general physics and college physics and calculus-based physics for those of you that are on that track. These units are all also very, very, very what we call high yield for standardized exams like the MCAT, and to a lesser extent like the DAT as well. So those of you that are thinking about pursuing a career in sciences, whether it's pre-med or pre-dental, or maybe some of you want to do research, there are many, many different applications of all of the material that we're going to be learning in AP chemistry. So take advantage of this time. Take advantage of these months that we have from November until April when the course is going to be running, and get a firm grasp of this material now so that you can get a firm grasp of more advanced concepts when you're an undergrad.
I want to just touch up on what you said again quickly.
Sure.
You said something about how you see a difference between the kids who took AP Chem and did not see it and did not take AP Chem. I want to make sure that is in fact what you said, because a lot of kids are advised that they don't need to take AP Chem or they don't need to worry about it. They're going to take it anyway when they go to college. They're going to take Gen Chem. So I just kind of, can you elaborate on that? Because the kids get quite a lot of guidance, and then the parents ask me, Queller, they don't need it. The guidance counselor said they don't need it. So I just want to clarify what you said before we move to the next slide.
No worries. So from what I understand, based on how standardized high school works in New York City, is that generally speaking, a guidance counselor would never say something to put the school at more risk than necessary. So the school doesn't want many kids taking AP Bio and AP Chem because it means that these kids are more likely, because these are more difficult classes, of course, these kids are more likely to have a little bit of trouble and to lower their GPAs and to make the school look worse because you're now applying to college and you're less likely to get in, hypothetically, if a student were to have a lower GPA based on this AP exam. But fundamentally, the information that's on the AP Chem exam, like I said, I do see a difference between students that absorb this information at your guys' level versus students that are just looking at this information now. I personally did not take AP Chem because it was not offered by the program that I was in. I took early college courses instead. And when I got to my undergraduate institution, I saw how the students that took AP Chem and really absorbed AP Chem and did well in it had a massive, massive advantage when they got to general chemistry. And it's not as if when you get to general chemistry, the teachers are going to start from the beginning. The teachers are going to say, okay, so most of you took AP Chem, so let's get to a little bit of the more advanced concepts, because they understand that since some students already have that background, they do not go into the basics with as nearly as much depth as they should. So I personally saw that I had to work maybe twice as hard as the kids that took the AP Chem exams so that we both got A's in general chemistry. And this is one of the reasons why I want to go back now and help you guys through the AP Chem process, because I understand how important it is as somebody who didn't have the opportunity to do this when I was your age. All right, cool. So we're going to talk a little bit about specifically what the unit breakdowns are like for your AP Chem exam. So a mole is basically the same idea as a dozen. When you say 1 mole of something, you're referring to one quantity of something. The exact number is, I believe, 6.022 times 10 to the 23rd power. Object is 1 mole. So just like 1 dozen is 12, 1 mole is that 6.022 times 10 to the 23rd power. So it's very, very easy and convenient for us to measure these elements in terms of moles, because 1 molecule of water, it's almost unfeasible to calculate. But when we're talking about 6e23 molecules of water, that becomes a little easier to analyze and a little more feasible to do thermodynamic manipulation with. That's why we have this concept known as a mole to make our calculations easier for us. Molar mass is a similar concept that I'll get into a little bit more during the actual course, but basically it's how many grams does 1 mole of this element weigh? And that's all dependent on experimentally determined values. and dependent on the density of that element due to atomic structure as well. So mass spectroscopy is an analysis tool that you can use to measure very famous molecules like proteins. And basically, I don't want to get too technical in terms of mass spec right now, but this is one of the most powerful tools that we have to be able to use X-ray techniques and UV techniques to be able to actually image and find the structure of very complicated molecules. So we'll get more into mass spec when we go through the material throughout the actual course itself. Elemental composition of a pure substance. So basically, like I said, water, for example, is a pure substance because it has a constant ratio of elements. So you have a constant ratio of 2 hydrogens and 1 oxygen always. And basically, we're going to be talking about how water interacts due to its elemental composition and how different atoms and different molecules with different atomic compositions interact. Basically, how the atomic composition builds up to the elemental composition of a compound and how that gives the compound certain distinct chemical and physical properties. Mixtures are a little bit different. So mixtures can be made up of molecules and compounds that have similar ratios, but mixtures themselves do not have the same ratios of elements to atoms. So a little bit different in terms of chemical and physical properties, but we'll talk about that throughout the course too. And electron configuration is basically a way for us to be able to organize the different energy states of the electrons. And these energy states of the electrons, we can use them to predict the behavior of the electrons, which is very important for determining how this electron is going to behave in a biological system. So electron configuration is very high yield on the AP chemistry exam. They have a couple different diagrams that they like to ask you guys about. So we're definitely going to go through that. But to a more broader extent, again, it's also important to have a thematic understanding that electron configuration lets us to have a way of representing the different energy levels of different electrons. Photoelectron spectroscopy, again, is another one of those really powerful tools. So basically, I don't know if you guys know this is how light works. So you excite an electron, it gets to an excited state, you add energy to it. When it goes back down to its ground state, so from excited back down to ground, it emits something called a photon. What is a photon? It's light. It's basically a massless unit of light. So that's all about what photoelectron spectroscopy covers. That's kind of the basis for what we're going to go through there and how we're going to use these properties of electron excitation to learn about the different techniques that are associated with this theory. All right. So if we could scroll down a little bit more, Unit 1.7 covers periodic trends. So one periodic trend I already went over is electronegativity. Other periodic trends include atomic size, atomic radius, and certain things called electron affinity. And we're going to go through exactly how the different atomic structure and atomic composition of each element plays into these periodic trends as well. So I think, Francis, I think that we glossed over Unit 2. We just go back to Unit 2 really quickly, just so I can give a brief explainer of those topics as well. So Unit 2, you have different types of chemical bonds, okay? The famous ones are going to be a covalent bond, which is a sharing of electron, and then ionic bond, which is more extreme, it's a transfer of electrons. So a sharing versus a transfer. The unequal sharing of electrons, this is maybe getting a little too technical, we'll talk about this during the actual course. An unequal sharing of electrons is what causes your partial positive and partial negative charges that we talked about. However, in an ionic bond, you have formal positive and formal negative charges. So they're not partial positive and partial negative, they're formal positive and formal negative. All right. Intermolecular forces, we talked about a little bit. I'm going to save a more in-depth discussion of that for the actual course because I don't want to go too deeply into the rabbit hole with these first couple of units. Ionic solids. So, Michelle Friedman. Okay. Ionic solids, the structure of them. So the atomic composition of these compounds are such that they want to either give up or accept an electron, and that's how these ionic solids are going to be structured. Their atomic composition is going to be that they want to give up or uptake an electron, and we'll go through specifically what all of that means throughout the course. But to a lesser extent, metals and non-metals do not share these properties. Metals and non-metals are a little bit lower yield for the purposes of the AP, but we'll go through that. Lewis diagrams and formal charge diagrams are basically ways of also representing the electrical composition of your element, of your compound. So I want to save all of that for the actual course, but that's just kind of a broad overview of what we're going to be going through in terms of the end part of Unit 2. So I think we're ready to talk about Unit 3 a bit. So Unit 3, one of the main things that they talk about, and one of the most important things for your AP exam, are the intermolecular forces. So just like international means between different nations, intermolecular means between different molecules. So there are certain forces based on the atomic composition of these molecules that cause them to interact with certain molecules and not with other molecules. For example, just one really quick analysis, you can have a polar molecule that has these partial positive and partial negative charges that we talked about a little bit. And you can have a nonpolar molecule that does not have these partial positive and partial negative charges. Polar molecules do not interact with nonpolar molecules. And this is important in a biological system where we want to predict the potential interactions that molecules have. We know that polar molecules are not going to interact with nonpolar molecules. All right, so I think we were still on Unit 3. So going back down to solids, liquids, and gases, these are physical changes. So these are physical differences in composition in terms of different representations of matter. Now, there are different thermodynamic properties that you can apply to understand how you get solids, liquids, and gases. This is going to be from your ideal gas law and to an extent from your kinetic molecular theory. But just to go through it very, very briefly, temperature is a measure of average kinetic energy. So when you increase the temperature of a system, you're literally allowing the molecules to move faster. That's why ice melts into water and then the water evaporates. Right? So on the ice, the molecules are moving slower because it's a colder temperature, which again is the average measure of kinetic energy. And then in the gas, the molecules are moving very, very quickly because you have high kinetic energy because you have high temperature. Right? So that's physically the difference between a solid. A liquid is kind of intermediate between a solid and a gas. And separations of solutions and mixtures chromatography takes advantage of a property known as solubility. So what is solubility? We talked about polar and nonpolar before. Basically, solubility is that polar likes polar and nonpolar likes nonpolar, right? So if you want to separate polar from nonpolar compounds, you can put in I don't want to get too technical here just yet, but you can basically spill your mixture of nonpolar and polar onto a polar piece of paper, and you're going to see that the polar is going to stick to your polar piece of paper. That's how you can better separate your polar and nonpolar compounds. But again, I'll get into why we want to do that and the more specific uses of that throughout the actual course. That's just a little bit of a broad overview. So moving on to chapter 4 now, because the rest of the chapter 3 concepts are a little bit lower yield. I want to focus on the more important stuff in this overview today. So net ionic equations are probably also another very, very high yield topic on your AP exam. So what a net ionic equation and what a reaction is going to be is that you have to have what's called a balanced reaction. What does that mean? That the same atoms and elements that come in are the same atoms and elements that come out. Although these atoms and elements can be rearranged, and they often are rearranged, it's still the same composition of atoms and elements, just arranged in different ways. But the list of atoms and elements in the reactants and the list of atoms and elements in the products is the same. Okay? We need to sometimes use algebraic manipulation to see how much of certain molecules we need to balance out this list of elements, and we'll go through that, what's called balancing a chemical equation, when we get to Unit 4 throughout the course, but that's just a little bit of an introduction to that. So next I want to talk a little bit about something called the titration. So what is a titration? Basically, you're taking advantage of acid and base properties to further analyze your mixture of unknown composition and to potentially further extract acids and bases. So that's a broad overview of the purpose of a titration. We're going to talk about a titration and oxidation reduction reaction. So as a broad overview, oxidation is the loss of electrons in a reaction. Reduction is the gain of electrons in a reaction. So obviously they happen in pairs, right? One guy loses the electrons that the other guy gains. So that's why it's called a redox reaction, as short for oxidation reduction or reduction oxidation reaction. It's called a redox reaction. Those are also very, very important for your AP Chem exam. And those probably cover the fundamental goal of your first year of general chemistry is redox. So really make sure that you get a good understanding of Unit 4, subsection 4.9, because that's going to be really important to you for the rest of your career in science. In terms of kinetics, we can go through, in terms of a broad overview, there's something called a rate law. Your rate law is dependent on the concentration of both reactant and product that you have in certain situations. You have different organizations of something called a first order, a second order, and a third order rate law that different molecules and different compounds follow. We're going to get more into rate law and kinetics as we dive deeper into the course. But another really important thing to understand is that in a biological system, many of our reactions are thermodynamically favorable. What does that mean? It means that they're going to happen by themselves. However, they sometimes take a million years to happen. Obviously, these are reactions that would need to happen within 1 or 2 seconds and not within a million years. So we have something called an enzyme. An enzyme, we're going to go through specifically how it does this a little bit later on. An enzyme increases the speed of a reaction, so it changes your kinetics, but it does not touch the thermodynamics of the reaction. So Unit 6 talks about thermodynamics. So Francis, I think we can move on to Unit 6. Francis, if you want to scroll down.
Yeah, I'm moving down right now. And can you just confirm, you'll see the kids who are participating in this, will they also see this on the SAT2 subject test? Because that was one of the questions in the group chat.
So again, the College Board is the same company that makes the AP exams and the SAT2 exams. These companies have a certain amount of MDs, PhDs, maybe people with master's degrees and years of experience in the field to make these questions. A lot of times there's going to be a lot of overlap. Of course, the AP Chem exam is a little more difficult, but if I had a Venn diagram, and I say the same thing about AP Bio, if I had a Venn diagram of comparing the AP Chem topics and the SAT Chem subject test topics, I would just have a circle basically, because the overlap between these two exams is very massive. Obviously, if you want to do really well in your SAT2, which a lot of top level undergraduate programs require you to do, you're going to need to have a little bit of a separate training for that, just to make sure that you not only have a good understanding of the content, which you're going to get from this course, but that you're going to have a really good understanding of the strategy as well. Because content can get you 80% of the questions correct. But I'm sure for the people that we have in this group at Queller, you guys want 5s on your APs and you want perfect scores on your SAT subject tests. So with that in mind, content is going to be similar between AP Chem and SAT2 Chem, but in terms of strategy, which is really when you get those last top 10 to 15 percentiles, which is what these top schools really care about, in terms of strategy, we're going to be better off studying separately the strategy between the SAT2 subject tests and the strategy between the AP Chem. But again, the content overview is massive. There's very little that's not tested on the AP Chem exam that is tested on the SAT2 subject exam. But of course, there are some topics that are not tested. So we'll go through those separately in Queller's SAT2 prep courses when we do get to that time a little bit later in the spring. But definitely the AP Chem exam is going to help you a lot for these SAT2 courses as well, the SAT2 exams as well. So kind of going back into our, actually maybe I'll just take this time to answer any more questions in the chat. How to determine the charge of an atom. So Faiza, that's a great question. It has to do with something called a noble gas. So we're going to get into noble gas and stability and how all atoms really want to look like noble gases. So they manipulate themselves with charges to look like a noble gas. And we'll get through that throughout the course itself. But I do want to make sure that we have enough time to go through an overview of the rest of the topics themselves. Atoms that are ions have a certain charge based on how many electrons that you gain or use. So Michelle, that's mostly correct. But again, these charges are going to be determined based on noble gas configuration, and that's another really key thing that we're going to see throughout the rest of the course as well. All right, and I think that that's it for the questions.
Okay, am I good? We're good where we are now, right?
Yeah. If anybody has any questions, please feel free. Okay, I think we're good. So I'm going to go through the rest of the units 6 through 9, and then we'll leave more time for questions towards the end. Thermodynamics, I talked about a little bit. So again, thermodynamics is the reaction going to happen? To determine thermodynamics, you have three main players. Those main players are going to be something called enthalpy, something called entropy, and something called temperature. I'm sure everyone knows what temperature is. Enthalpy is a little bit technical. I'll get into enthalpy during the actual course. Entropy is basically a measure of randomness. Okay, so you have a solid. Actually, let's think about it in a little bit of a better way. You have a organized reactant that's then going to increase in disorder and become a less organized product. That is going to give you an increase in entropy, because entropy measures a way for us to think about it. It's not a super technical definition, but entropy measures randomness. For the purposes of the AP Chem exam, that's a good enough understanding for entropy, definitely. So entropy measures randomness. Enthalpy measures, for our purposes, again, it's a little technical, so we'll get into exactly how a little bit later. Enthalpy basically measures strength, and temperature, as we know, measures average kinetic energy. So these three players, average kinetic energy, strength, and randomness, interact with each other, and we'll see how different formulas are going to show us the interactions between these three players, and how if we get positive or negative numbers for certain what are called thermodynamic Gibbs free energy values. Again, we're going to go through all of this during the course. We have certain positive or negative numbers that tells us whether the reaction is going to happen or not. Okay, so that's a little bit about Unit 6. Unit 7, like I said, your body wants to be in a constant state of equilibrium and a constant state of homeostasis. With this idea in mind, you have a lot of different ways to maintain equilibriums. I don't want to get too down the rabbit hole here, so I'm gonna gloss over the specifics of equilibriums and just say that you have something called the Chatelier's principle. So the Chatelier's principle is if you have the reactants and products in an equilibrium, right, which means that they're kind of sort of in equal concentrations to each other, unofficially, and you raise the amount of reactants that you have, your reaction to get back to equilibrium is going to subsequently raise the amount of products that you have. So this manipulation of equilibrium is very useful for us. When we want more products, we know how to get them, we add more reactants. And that seems really simple, but actually if we decrease products, we're actually going to be also decreasing reactants in an equilibrium system as well. And that's a little bit more of a complex idea that we're going to go through throughout the course as well. So it's not just that a decrease in reactants gets you a decrease in products in an equilibrated system, it's vice versa as well. And we'll go through that throughout the course. So now shifting a little bit to acids and bases. Acids, like I said, like to donate hydrogens, and we'll go through what it means to donate a hydrogen and to accept a hydrogen, and bases, like we said, like to accept a hydrogen. So basically what this means is that you have certain molecules and certain compounds that you have known properties of acidity. An example of this is HCl. HCl is commonly known as hydrochloric acid because the Cl minus is going to want to very, very frequently dissociate, and the H plus is going to want to very, very frequently dissociate. So again, we'll get through the specifics of this when we talk about electronegativity. Again, also just showing you how different areas of content overlap on the AP Chem exam. Cl is very electronegative. It's better suited than O to carry negative charge by itself. So if you have HCl in water, that becomes Cl minus and H plus very quickly. So HCl is a very strong acid. And this is again due to the atomic structure of Cl. So we're seeing how these earlier units build up to these more macro topics that we're going over now with the acids and the bases. There are certain also equations that we need to go over, things called pH and pKa. So whenever you guys see a lowercase p in a chemical system, that lowercase p refers to something called the negative log function. And what exactly that means, we'll get through in the course, but just don't be scared by that lowercase p. It's basically just an algebraic simplification. All right, so I think we can get to Unit 9 now. And Unit 9 is basically talking about how we can take these thermodynamic principles that we talked about before and use them to our advantage. One very, very famous application of this is ATP. For those of you that don't know what ATP is a molecule that hydrolyzes or breaks very favorably. Now, there's a very, 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 very negative number that ATP has of a property that we'll go through a little bit later on, but just keep in mind right now that ATP has a very, very negative property for thermodynamic favorability, which actually means, it sounds weird to say that you're negative but you're favorable. The negative property in this specific case means that the reaction is likely to happen. That's a little bit technical, but what this basically means is that if I have ATP breaking down, which we know is very, very, very favorable, I can literally add that to a reaction that I need, but a reaction that's not very favorable to make the overall reaction favorable. And that's why we need ATP in our cells. So again, that was a little more technical than the rest of the review, and I will dive more deeply into that when we get to Unit 9. But that's just one example of a thermodynamic application and how they can test it on your AP exam. Another famous example is something called a cell. So I mentioned before that car engines are basically chemical cells. There are many types of cells that are important for the purposes of the AP Chem exam. The two more important ones are called electrolytic cells and galvanic cells, and we'll get into them separately and how you can get tested on these different topics on your exam. But that's just a little bit of a broad overview on the different topics that you can expect on your AP Chem. And of course, throughout the rest of the course, we're going to be going through not just the content like we did today, but I'm also going to be getting practice problems and homework questions and anything else that will help students with the exam. So I think in terms of the content overview, that is it. So if you guys have any questions, I'll be more than happy to answer them. Whether questions about the exam or questions about my own background as well. I mean, feel free to ask away.
And I also want to add, why would you encourage kids to take the AP and the SAT 2 Chem? Like some kids, I'm so sorry. I'm saying,
no, of course.
Some kids, like, I just want to tell you, this is what I hear. The parents are like, oh, well, this year we'll do AP Chem. Next year we'll do SAT 2 Chem. Like, they want to space everything out. What do you recommend?
I can't stress highly enough the importance of not wasting time and the importance of not having to relearn everything that you're already learning for one set of subject tests for another set of subject tests. I'm not specifically referring to just the SAT subject exams, but just in general, you already are going to be learning the vast majority of the content that you need for your SAT subject exam in your AP exam. We're going to be going through it. Like I said, of course, there are some slight differences in strategy, and we have a quality prep course that's going to be specialized for the subject exam that's going to go over the strategy. I'll most likely be working with that course as well. But the AP content is something that's very similar to your SAT Chem content. So it really doesn't make sense to do your AP now, forget all of the content, and then take your SAT 2 subject in a year. The SAT subject exams are not that hard. They just have that little bit of strategy that you need, and that little bit of strategy boost is what we give here, of course, and that's in addition to the content that you guys are going to be getting throughout this AP course. So I would very, very highly recommend for any AP that you take to take it in a complement with the SAT subject test. Many undergraduate institutions, especially the prestigious ones, and even if your institution is less prestigious, they have very, very competitive scholarships that like to see these SAT subject exams and like to see your performance on them. So AP exams are very, very fancy. Colleges like to see them. It shows the upper level colleges that you guys are serious students. And SAT 2 subject tests, it's just another tool that you're going to have in your bag to also show your absorbing of the general chemistry understanding. Because the college doesn't want you to come in and know nothing, and the college is going to have to teach it to you. The college wants you to come in and basically be finished product. So you just come in, you get A's in their courses, and you go to medical school with your A's, and the college looks better because you went to medical school from that college. So they want to give you an A, and they don't want you to necessarily learn from them. They just want you to know the topics in general. So when the college sees that you've already taken AP Chem, you've already taken SAT 2 subject Chem, and the best way to show them that you have a good grasp of this material is by doing really, really well on both of these exams. And the best way to do really, really well on these exams is by not wasting time and by like knocking out two birds with one stone and studying for your APs in the same year, in the same time frame that you're studying for your SAT 2 subject exams. That college is going to be more likely to accept you because they then want to see that this student is going to get an A in our chemistry course because of their great understanding of chemistry already. So that's what I would say in terms of the necessity of taking the AP exam and the SAT subject exams relative to the ones that are in the same topic fields together or within a short period of time. So I see we have some questions circulating in the chat. Let's see here. Can you take SAT subject exams in your sophomore year? I think Francis would be a little more able to answer that. So Francis, do you know if College Board lets them do that?
You can schedule SAT 2 subject tests, and you can schedule them at any time. So 9, 10, 11. But I mean, at Queller, and obviously it makes more sense to take an SAT 2 subject test the same year that you're taking the corresponding advanced placement class. Right. So you shouldn't have a wait or a gap. I mean, it just makes no sense to take AP Bio and then wait a year or 2 or 3 exactly. And then take it just makes no sense.
Yeah. And to touch a little bit of what I see another student here talked about, Samori Khan said you already took the AP last summer, but you didn't take the SAT subject test at that time. Would it be better to take it this December instead of May of next year? I'm going to be completely honest with you. This is probably the one case where I would recommend waiting until May next year, just because that's when our course is going to finish. And the SAT 2 subject exam, while the content is similar, again, the strategies are a little bit different. So our optimal goals here are going to be to get you guys ready for these exams in May. And with our team, you're going to be in a really good position to do that, in a better position than you would be if you rush a little bit and take the exam in December. It's one thing to say when you're studying for your SAT subject test and your AP exam at the same time, to have those different goals in mind and to be able to do that at the same time. It's a different thing to say, I studied for my SAT subject test. Now I want to take my AP exam really, really quickly. It's unfortunately, it doesn't always work out the best for the students when they rush the exams like this. So that's just a, kind of a little warning that I would give was, would be don't rush when you take the AP. Synchronize it with your SAT subject to the best of your ability, but make sure that you're doing the synchronization in advance of when you're taking these exams. Would be my advice on that.
And then just to be
sure.
very clear, with the college application,
Yeah.
you are checking a different box. They're going to ask you in the application, list what advanced placement courses you've had, list which classes you want to try to get the credit for. Then they have a separate column on the application, a separate page, separate everything. Okay, what subject tests have you taken? So you're answering different parts of the application. And that's also very important. I always tell the kids, we're working in a lot of applications now at Queller. And I always tell the kids, you can't leave 50% of the application out and then wonder why you didn't get into certain schools. The BAMD programs, the BSMD programs, all of the dual degree, Stony Brook, Sophie Davis, everything that has the 4+4 or any of these dual degree programs, or even, I mean, the Pliny, Brown, you need to make sure that you have every single box checked. So if you're taking an AP, you should also be taking the corresponding SAT 2 subject test. Also, as Sam said, the content is so similar. So why wouldn't you take whatever exams you can, right?
Exactly. So I see two more questions popped up here that are of similar orientation to what Francis was just talking about. So the first I'm going to ask Tiffany. So you're talking about the format of the exam, especially in terms of juniors. So that, and in terms of the strategy and how we tackle the format, we're gonna say for the actual meaty part of the course itself, just because we want you guys to do these practice questions under timed and kind of, in a slight sense, under a little bit of pressured situations, so that we get an understanding of where you're at in terms of the mindset that you're going to have when you're hypothetically taking your actual AP exam. So I'm going to save the format stuff for the actual course. Omesh, the major difference between the chemistry subject exam and the AP chemistry exam is that the AP chemistry exam is generally a little bit more research based. So the AP chemistry exam is going to be asking you more for these kind of like upper level analysis questions. However, the SAT subject exam likes to get into a little bit more of the technicalities. So I would say the subject exam is a little bit easier, but they are fundamentally different and they do have different strategies. So I hope that I answered your questions about the difference in strategies. So APs are a little bit more research with a little bit of an aspect on the technical aspect of things, and the subject exams are more technical with a little bit aspect of the research side of things as well.
So guys, we're actually going to finish. Believe it or not, we're running a physics. I've learned so much science in the past 2 days. So I do want to, and it's all coming back to me from high school. So I do want to share with you. So we're running a physics review now because it just worked out with the tutors and staffing. So I'm actually going to switch over on this Zoom account to the AP physics lesson. So we're definitely very busy. I do want to encourage everyone, please, number one, let's give Sam a huge thank you. So if you could just type into the chat box, let's give him a huge, gigantic thank you. And I'll start by typing thank you into the chat. And if you want, you can go off mute and you can say thank you as well. So everyone, let's give him a big thank you for his time.
My pleasure, honestly. I had fun.
And for doing this. And I guess a thank you to me. I listened to chemistry for an hour. That's a new one. The other thing you should know, please consider signing up for the course because Sam is teaching it. He has a pretty busy schedule and he's making time to teach this class for us. And he's gonna, as always, we're gonna play to win. So we definitely want you to be part of this course. If those of you are interested, this is going to be in Zoom. If you guys want to come together, we're open to running this in person. But again, we would just like you to form a group so that we have it. And that's important too. We would be open to doing an in-person course if you get the kids. We're going to log off. We're going to start the physics one. And just remember that right now in Unity, there is strength. So hopefully we're gonna see you and we're gonna join and we're gonna learn this material during such a crazy time in history. That's it. What can I say? We're gonna log off. And Sam, thanks for teaching me some chemistry. Who would have ever, never say never, guys. Queller Prep runs kindergarten classes, AP Chem, Gen Chem. Who would have thought? Okay, thanks guys. Thank you everyone. Thank you for participating. All right, take care. Bye.
See you guys.
Thank you. Bye.
Thank you.